I'm Andy Terrell, the VP of Data and Algorithms at Xometry. I'm here to talk a little bit about using semantics in your data ecosystem. This talk is not necessarily about anything at Xometry, but about my experience in running AI at enterprise scales and data systems at enterprise scales. Also, you might have seen me. I've been worked in startups in real estate space. Was on kind of the founding team of Anaconda and the world-renowned nonprofit No Focus, which supports tons of open source machine learning libraries. To get started, to tell you about where we're at, like maybe the beginning of the rant, then my kind of coming to like looking at semantic web systems for incorporating a better ecosystem and a more fully kind of realized the usage of data at these large systems. And then just kind of a couple of applications of how you can use provenance. It's like data sets and semantics on events and so forth, and how some of these ideas are kind of coming about in enterprise data architectures today. But first, let's talk about how we've gotten here. Whenever you look at data architecture, you get things like this, which has nice boxes, some clients, some like APIs, and these nice arrows and whatnot, and data streams and APIs. This one is Facebook, and you can kind of see there's a link in the notes about a whole bunch of these going through. And it's not so bad. You're like, all right, I have some streams coming in, I have some parsers and some schedulers. It does something, don't know what, don't know anything about the data. Pretty sure there's data flowing through pipelines. You get to Airbnb, and it's like, all right, we actually have MySQL in here, so we know there's a database involved, and we know some events, and then you get into Hive and Spark and Presto. Really not much about what's going on in this data infrastructure. And then here's an example from Netflix, which has all sorts of streams coming into control planes. It goes into, for example, storage and another one stream into another stream into different consumers, and gets kind of, not still very abstract. What are we actually doing? And that's actually only the blow up of like this very large picture, which I could not tell you what it means at all. After going to conferences and talks about this for many years and seeing these sorts of slides over and over again, I always ask the question, what does that have to do with machine learning? What does that have to do with AI? Why do we have all this like complicated data structures and data systems when really the place we start is more along the lines of the data and a server? All I really need is my computer hitting some piece of data, could be relational, could be document driven, could be tabular, I don't care, and my computer. And more to the point, to an enterprise, they don't think about Kafka and all these customer data platforms and all these other things. They think about it as they have a sales team, they have an accounting team, they have a marketing team. Each one of these have various applications that produce data. Those produce the little bits of schema that we in documents that my program could now pull down and do things with. So how did we go from a community talking about things like this when the business world really wants just things like this? And I want to kind of share a little bit about my view of how you actually bring the data back into the AI architecture at enterprise scales. And so to do that, I want to introduce you to a few concepts for the semantic web. So semantic web's been around for a long time at this point, and a lot of folks, like if you start talking to people, they're like, oh yeah, that failed. You can't really use semantic web in many things very easily. And the truth of it is like, no, semantic web technologies still underpin the backbone of a lot of data technologies that are being built today. And even more so, they're allowing us to actually know where data is being generated and being brought into your business. So it's not good enough just to know I have data from a pipeline. You really need to know, hey, this is a sales call that was made, or this was a visitor to a marketing page. quite different types of people if you are trying to identify who's going to churn or who's more likely to buy something from you. A visitor to a web page has a much lower probability, typically, than a qualified sales call. So, as we're building out systems for the enterprise, it's not good enough just to have these pipelines of data coming at you. You really have to know a lot more about the data in order to use your models and to provide business value. So, two concepts from semantic web is RDF and OWL, or or ontologies. RDF, for resource description framework, I believe, uh, was a way to really describe your data in a universal manner. Okay, so at the beginning, when the web was young, it was just basically bits on pipes and computers, and you got to just like get what you want. You had to parse it. You had to do out all the things you'd like. Along comes the schemas and other pieces of saying, oh no, this web page is about a person, and this web page is about perhaps a location. And so in there, you needed a way to tie the schema in a universal manner, hence universal resource locators or URLs, with the actual content on the page. You can do the same thing with your data. Here, if I have a relationship or an entity of I for example, I have Paul Schuster from Dresden. And this is a classic example from uh, the W3C community's documentation on RDF. So Paul Schuster was a person, and we can tell he's a person because he's attached to the relationship of a person, and he's also attached to the his birthplace to the entity inside Wikidata of Dresden, which we know is a place. And so by using predefined schemas and places and entities from universal source, you're able to know exactly what these two people are and query the system in a meaningful way. Now, I always like to ask how many Salesforce engineers out there have seen the pick list of a Salesforce drop down that has like same stuff over and over again, just misspelled or changed a little bit in one form to another form. Maybe it's for my case in real estate. Maybe we have a house that's a multifamily unit and one that's uh, a single family unit, and sometimes we're asking like some silly questions such as like what's the cost of lawn care or the cost of plumbing. Well, these are very different questions and different kinds of facilities. And you also got into the point where people might ask the same question in two different ways, but get radically different responses because of the way they asked it. So if I ask, "Are you looking to move in the next 6 months?" versus "When do you look to move?" Right? One's a free form text, one could be a pick list, but they're both the same fundamental data underneath. By extracting this out and actually using a schema with a universal locator, we're able to like hone in on our applications using understanding what is actually happening uh, on the phone with a salesperson or in a form on a marketing site or in a ledger in an accounting sheet and so forth. The next one I want to kind of present to you is OWL, or ontological web language. And OWL is a great way to take these entities, these uh, ontology items, and actually compose them to represent your data. So instead of objects, like if you think about object oriented programming says like I have an object that has this data. Flip it on its head. I have this data, therefore it is this object. And my favorite view of this with Python already is an implementation of the OWL language, and they use the pizza ontology. So if you define a pizza, and I just say I want a non-vegetarian pizza, you could define a non-vegetarian pizza as all pizzas that have the combination of toppings that are non-vegetarian or that are meat or meat toppings or so forth. Or you can say, hey, if it's got meat on it or fish, because yeah, some people like define it differently. Um, we're just going to call it non-vegetarian. And guess what? We're going to add our own method to this. Eat, for example, it says like, no, 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 I'm a vegetarian. I can't eat this pizza. So think about that. So if you have a questionnaire from a sales team that comes in, it's like, have you bought a car in the last 6 months? Do you own a home? Like all of a sudden, you're a homeowner and a car owner. I don't have to add a whole different logic for the various cases by looking at all the different pick lists inside your sales form. Using this concept, we've been able to build lots of workflows that, all right, if this person is in this audience group for the marketing team, perhaps we go down this drip campaign. Or if it's this sort of offer that could be made, perhaps we alert their salesperson at some point. And instead of focusing so much on defining exactly the object and then the data and letting the data define the object, we're able to use all of our data in a very cohesive way. All right. So I've promised to say, how do you bolt this into your current systems? Because as we all know, most of us went off and built stuff like this because Strata told us to. And now we're in this situation where we don't really know what the heck our data is doing. So how do we use these two these two technologies in the enterprise today? The first one I'll call I've used quite a bit in my own custom ML pipelines is to just to get provenance. But provenance at even like the level of like which system is something coming from, if we try to get to that beloved ground truth of data, you really need some way to tell me how that got there. The W3C specification I like here is called prov. Sometimes you can go to the Provo documentation. You can see it there in the link in the slides. Um, and it essentially comes down to three objects. You have an entity, an activity, and an agent. Okay, so the entity is whatever was actually being worked on, whether it's a document or a lead or a form or whatever it is, like some entity. You have the agent, the person, the salesperson, the customer, the actual employee, whoever it was. And you have the activity. Did they generate this? Did they fill in the form? And and there's some other things that could be highlighting and more metadata added to it, such as were they informed by another activity? Was it associated with a different agent? And even here, often I say like your machine learning often becomes just another agent inside your system. So if I start modeling my data in this way, and to say AI just becomes another agent or another a bot or program that produce these entities and activities inside my platform. It becomes much easier to say, oh, I derived this result from this program at this time through running whatever script it was run versus, oh yeah, the human told us. A good example is like, we think this person is worth $150,000 a year, and this person, we know they are based upon like the what the salesperson told us. And so even that little bit of knowing like that one bit of data, where did it come from? Well, it's really hard to do that at every granular level. But if we go back to our example where we have Salesforce or NetSuite or WordPress coming in, we know the data set that's bringing that data in, and when we're querying those data, the actual form as they get compiled together, either through a materialized view or through whatever pipeline, you can bring along the provenance of that data piece at the data set level. And so the way I've always done this is, once again, for Python, because I'm that guy, using a prov kind of document. So every document that comes in gets written to some place. For example, here's crime and punishment. I think. Oh no, just a different example. But here's the case where Alice has a crime file and says like she created the content inside this file, and so programmatically, whenever I'm running my scripts, I can actually upload these prov documents either to a metadata inside the tables or on beside it inside a file system or so forth. Okay. So right away, I'm able to take this sort of concept of an RDF, apply it to provenance to my data sets, and immediately I start to see the the lineage of data coming into my models, and also able to tell what the perhaps what my model, like the audience who's like seeing the produced model result, or maybe it's actually just straight from the database, and give them some sense to explain why your AI systems are coming up with the answers they're coming up with. And as we all know, salespeople don't trust anybody. So, like, if you give them a little bit more, just a little bit more explanation about where that data came from, it helps them understand how well their system they should be using, and so forth. Um, yeah, so you don't have to do it in the way I do it. You can do very much these same concepts are alive and well. For example, you have DBT that does the transformations of all these different data sources together into a single materialized view. You have Open Lineage that can track the model runs and the characterization of data and so forth in a nice track traced format, and then Marquez, which is like a nice visual system for it. So even if these ideas are not something you're applying today in whatever you're working on at this moment, you're able to see how the industry is moving towards the semantic systems, even as we speak, under the tools that are becoming standard. All right, the next kind of idea for using semantic data inside your data ecosystem and bolting it onto that current monstrosity of an architecture that you have that nobody quite understands, um, is the using it at the event level. As we kind of know, the world really is event driven. Like, somebody shows up the store, they want to buy a thing. They show up at your website, they click on a few items. They make a phone call to a salesperson. These are all events. And so if you have a system that can't handle the actual event, you actually lose the data a bit. I think one of the most tragic kind of things I see in a lot of small teams is they build out like a fully transactional system, but they never actually capture the events that lead up to that transaction. And so, moving into that event driven world, we've adopted microservices, and like you can kind of see of it. And this is a very nice diagram showing like you have some event bus that comes in, and you have requests from all sorts of places happening at the same time, and things are both receiving events and taking events away. Okay, so the challenge here is the same as that Salesforce example, where you would have the perhaps the wrong pick list versus the inputted form. And how do you keep all this stuff straight? If microservice one is talking to microservice two in the wrong way, how do we know what happened in between the states? Once again, inner schemas. So today, if you go to Kafka, you have like this schema registry. And the reason I was going to put up here some like details on like protobufs and things like that. But at the end of the day, like, really just having a way to describe what those events are coming through your system, and using something like a protobuf that actually gives you description of the data. From that description of the data, now you can have attributes on the event, and then use owl to actually tell you which events are coming through. Oh, I had a customer come through, I hold their events. All of a sudden that customer um, bought something that turned them their lifetime value into like twice as much. Now you have a high value customer. And from the same piece here, by just focusing on the building your ontology into your schema, and even we see this with things like the schema registry. Like, well, we're already registering schemas inside these event buses. We can now pull it in web ontologies, and then um, understand the events that are coming through the same ontological viewpoint. And been doing this for a few projects, and it works wonders. It's no longer am I looking staring at my code asking, well, why do I think this is a high value customer? Do I have to go back and like look at all of, like, the different values that are available and plot a distribution to see what my uh, quartiles are, and so on and so forth? You just put in there quartile is greater than such and such, and hey, how did I get that? Well, you could query it from your database, or have something dynamic determine the data that qualifies for that particular person or so forth. So yeah, so very simple. We already have registries coming in. We're already able to use codes that able to transform your objects and then build. Maybe it's a email service, maybe it's a discount coupon, whatever it is that's you're going to be building into the events that are coming through your system. Um, before they go to any sort of transactional system or is just the processing of something three or four kind of steps down the line. Okay, so thanks so much for your attention. I hope you learned a little something. These big systems, you love them. They're what got us into big data. They showed us so much of the path of being able to organize data and put the pipelines. But yeah, if you don't tackle that kind of question of what is this data, what does it mean for my system, you end up limiting your ability to really use that data machine learning models as effectively as you could. I hope that maybe you've taken away a few ideas from the semantic web technologies that you're able to put to use and maybe even see how the evolution of some of the major systems are moving as they as we evolve into, I don't know, maybe the postmodern data stack as we move away from just only big data for big data sake. Thank you so much for listening, and I hope you enjoy the picture of the kittens from Unsplash. Thank you.